Something's wrong with the sky, and nobody wants to say it out loud. Here's the thing about the universe. It's supposed to be slow, patient. 13 billion years slow. That's the deal. Gas collapses, stars ignite, galaxies clump together over unimaginable stretches of time. That's the rule everybody agreed on. Nobody broke that rule until we built a telescope good enough to actually check. And now we've checked, and it's broken. James Webb keeps finding galaxies that are too big, too old, too mature, sitting in a universe that by the clock had barely finished boiling. It's like walking into a hospital delivery room and finding a full-grown man standing there 5 minutes after the mother arrived. You'd ask questions. You'd want answers. Well, so do I. Now, before you get scared or excited or whatever you're feeling right now, let's slow down. Because there's a question hiding underneath this question, and it's one most people skip right past. How do we even know how old something is? You can't just look at a smudge of light in a telescope and go, ah, yes, that's 13 billion years old. That's not a fact you read off a label. That's a conclusion. And conclusions can be wrong. So let's build it from scratch, the way I like to. When you look at a distant galaxy, you're not looking at a galaxy. Not really. You're looking at a letter that was mailed a long, long time ago and is only now landing in your mailbox. Light takes time to travel. That part everybody knows. But here's the part that trips people up. While that light is traveling, space itself is stretching. Not the light moving through fixed space like a ball through a hallway. The hallway itself is getting longer while the ball's in flight. Think of a rubber band with a wave drawn on it. Squiggly little wave, drawn in ink. Now stretch the band. What happens to the wave? It stretches too, gets longer. And light works the same way. When its wave gets stretched, it gets redder. That's what redshift means. It's not a metaphor. It's not fancy math for its own sake. It's the literal fingerprint of space expanding while the light was mid-flight. So when an astronomer says, this galaxy is at redshift 13, what they're really saying is, this letter took nearly the entire age of the universe to arrive on our doorstep. The redder the light, the older the postmark. Okay, now you've got the tool. Let's use it. Because here's what Webb actually found. And I want to be specific, not vague, because vague is where confusion hides. There are galaxies out there, some with names like JADES-GS-Z13, showing up just 3, maybe 400 million years after the Big Bang. That's not early in some casual sense. That's early like the universe just opened its eyes. And that alone would be interesting, mildly surprising, a footnote. But that's not the strange part. The strange part is that some of these galaxies aren't just existing early, they look organized. They've got mass, structure. Some of them even hint at disks, actual shape, actual architecture, when our best models of the universe say matter needed way longer than that to clump together, collapse under gravity, light up into stars, and arrange itself into something resembling a galaxy. It's like a recipe. You've got a cake that needs 3 hours in the oven. That's the rule, that's the physics, that's not negotiable. Gravity doesn't rush. And Webb keeps finding the cake, fully baked, frosted, decorated, at the 20-minute mark. Now, what do you do with that? As a scientist, you don't panic. You don't throw out gravity. You don't announce the death of cosmology on a Tuesday. You do what you always do when the data refuses to behave. You look for where your assumptions might be leaking. And there are basically 3 places the leak could be. I want to walk through all 3, honestly, because none of them is obviously right, and I think pretending otherwise would be a kind of lie. Door number 1. Maybe star formation in the early universe was just faster than we assumed. Maybe those first clouds of gas weren't shy. Maybe they converted into stars with brutal, almost violent efficiency. No slow simmer, no timid trickle, just go. That would mean galaxies could bulk up in mass much quicker than our tidy models predicted. Possible, not proven. Door number 2. Maybe we're being fooled by the light itself. See, a galaxy full of young, hot stars can glow in a way that looks, from a distance, suspiciously similar to a galaxy with an actively feeding black hole at its center, what we call an active galactic nucleus. If some of that light we're crediting to a whole lot of stars is actually coming from a black hole gorging on gas, then we've overestimated the mass. We've overestimated the age. We've been comparing a bonfire to a birthday candle and mixing up which is which. Door number 3, and this one's the uncomfortable one. Maybe the dating method has a wrinkle in it we haven't found yet. Remember, redshift only tells you an age if you already know exactly how the universe has been expanding this whole time. If there's some subtlety in that expansion history we haven't accounted for, some piece of the puzzle sitting quietly in the dark, unnoticed, then the whole timeline shifts, not by a little, possibly by a lot. 3 doors, 3 real possibilities. And I want to be honest with you, because that's the only kind of scientist worth being. Nobody knows right now which door is the right one. Maybe it's all 3, a little bit each. Maybe it's a 4th door we haven't even built yet. That's not me dodging the question. That's just where we actually are. Standing in the hallway, looking at 3 doors, guessing. And here's where I want to stop you, because there's a trap right here. A trap I've seen people fall into 1,000 times, and it's worth naming clearly. We give things names. Early massive galaxy formation, possible AGN contamination, expansion history uncertainty. And the moment we've got a name for something, it feels like we've explained it. It feels tidy. It feels solved. It is not solved. I've said this before in other contexts, but it bears repeating here because it's exactly the situation we're in. You can know the name of a bird in every language on Earth. You can rattle it off in English, French, Japanese, Latin, and at the end of all that, you will know nothing whatsoever about the bird. Not what it eats, not how it flies, not why it does what it does. You'll just have a very well-decorated absence of understanding. That's where we are with these galaxies. We have labels, sharp, technical, official-sounding labels. What we don't have is a tested, working mechanism that actually explains how this much structure showed up this fast in a universe that young. We have candidate stories, interesting ones. Some of them might even be true. But a candidate story isn't physics yet. It's a hypothesis wearing physics coat. And I think that's actually the most important thing I can tell you tonight. Not the galaxies themselves, but this. The discomfort of not knowing is not a failure of the science. It's the leading edge of it. If we had it all figured out already, Webb wouldn't be interesting. It would just be confirming what we expected, over and over, forever. Boring, safe, dead end. Instead, we built a sharper eye, better mirrors, colder sensors, more careful engineering than almost anything humans have ever made. And we pointed it at the deepest past we could reach. And the universe looked back at us and said, "You don't understand time as well as you thought you did." Because that's really what's underneath all this. This isn't fundamentally a story about galaxies. It's a story about our confidence, our quiet, comfortable assumption that we know how fast things can happen, how fast gas can become stars, how fast stars can become galaxies, how fast complexity can assemble itself out of near nothing. And every single time in the history of science that we've built a better instrument, a better microscope, a better particle collider, a better telescope, the universe has handed us a fresh, impossible thing, not as a punishment, not as a trick, as an invitation. That's not science failing. That's science working exactly the way it's supposed to. So let me leave you with the image I keep coming back to late at night, thinking about this. Zoom out from one anomalous galaxy, one tiny, stubborn point of light that showed up too early, too built, too complete. Zoom out past it, out through the whole deep field, thousands of galaxies crammed into a patch of sky smaller than a grain of sand held at arm's length. Zoom out further, out past all of that, out to the entire observable universe, shrunk down to a single dot. And then follow that dot all the way back through billions of years of stretching light, back to a human eye on a quiet, ordinary planet, an eye reflecting that dot right now, trying to make sense of it. We didn't just find something the universe wasn't supposed to have. We found out how little we actually understood about how fast the universe is capable of building things. And you know, that's a better discovery than an answer would have been. An answer closes a door. This keeps 3 of them wide open and dares you to walk through and find out what's actually on the other side. That's not a small mystery. That's a big one. And I, for one, am glad it's still standing.